Good morning, my friends. Today we are going to discuss about the Schrodinger wave equation. Yesterday what completed, we will continue the wave functions bit. Yeah. So up to here we completed yesterday. So in that we have 2-3 bits extra bits. So based on the fundamental what we learned in the previous classes. For example, normalization is there in the properties of the wave function. What are the properties are there? Finite everywhere, continuous, not only continuous in the x-axis, y-axis and z-axis of that particle. If you take the first order derivatives of that, for example, wave function with respect to x, wave function with respect to y, wave function with respect to z. So these are the differentiation equation. It means that the particle where it is going to change along with the coordinate axis. It means it is the first order derivatives. In the first order derivatives also, as the x coordinate, it is definite, it is a single, it is a fixed, like that only it will help. So therefore we can call it as, we can write this as, in the first order derivatives also continuous and the single value everywhere where it is going to define. For example, if you take the box or this, you keep one particle here inside the box. Okay, see, this is the particle. This is the particle I am keeping in the box here. So you think that this box is a wave particle, is a wave packet. So this is the wave packet. Are you able to see this one? Or you are able to see the water droplet here? So it is there, water droplet within the box or within the packet. But we cannot find the accuracy of this position. We cannot find the accuracy of this momentum. But we can determine approximate value, that is the uncertainty of its position. That only we studied in the Heisenberg uncertainty principle, and we studied the properties, and we studied the physical significance. Among those physical significance, one statement I would like to share once again. What is that? Normalization. What do you mean by normalization, sir? So, for example, the wave function, whatever it is, droplet of the water or the paper piece I kept here, it is a particle or electron. So it is, I am moving, rotating here, means it may be in the x or y or z, okay, or with respect to the time, the position will change. So these are the some properties we know that. Now, one property is there among those property. What is one property? We cannot determine, we cannot measure directly, because sometimes it looks or it feels that there is a particle, there is a observation, there is a assumption to probability finding the particle, but it is not definite. Why not definite? Because its value may be negative. For example, I am taking class to you. You are there, but I cannot find physically. If your video is not there or virtual is there, so that we make a positive means I will take up in the classroom. That's why what you will do, you take the one negative, another negative, you multiply the negative two digits, two integers, two particles, it will be positive only. Therefore, always that same value within the modulus what indicates within the two vertical lines, means always it should be in the positive criteria. Never will take the negative. Therefore, modulus will use in the mathematics. So therefore, same thing, whatever the wave function sign or the abbreviation or the notation I take here, that should be in the modulus. Now, second point, so that modulus is, that wave function value is within this box. For example, it is the end 0 to 10 centimeter. It means box, this bottle length is 10 centimeter. Therefore, integration of initial 0 to 10, I will write integration of 0 to 10 under this box means modulus of sine square, along with the x means dx, along with y means dy, along with the z means dz. Instead of that, we can write dv also. dv what's a full of this volume is a v, you take change of element in the particular area, that is a dv take, then we can write this as a dv also. That all equal to one value, 1 or n square. What is the 1 and n square? Here 1 is a finite, a definite number, that is indicating that there is a probability of the particle in the box, but not exact. So this way you make this particle from the negative, imaginary, or zero number to the positive finite only. This is the way how to make the normalization. Among those properties, I extended myself on point. What is that point? Minus infinity to plus infinity, sine square dx dy dz, or sine square dv equal to 1, along with x, y, z, whatever that may be, element volume will be changed. Okay, so that equation what I call as a normalization equation. Making this equation is the process we call as a normalization process. The 2-3 marks he may ask you, okay, that you write. So it will include in the properties. So if probability of finding the particle means is must and should satisfy the equation 1, that equation. Okay, for example, this is the classroom is there. Door entrance it is 0 centimeter and door outside is a 100 centimeter. What will apply here? Integration of 0 to 100 centimeter. Within that only the particle will move. I am the particle means within that boundary only I will move. So, but we don't know exact, but we can assume that it is at the center of the classroom only. It is the center of the classroom only. That's the particle where it is there. Depends upon the time and depend upon the position. So we can write its uncertainty principles. So when you make it a normalization. So once again I am repeating myself. Normalization equation means within that boundary minus infinity to plus infinity of sine value under the modulus of square modulus means square y. For example, y square, sir. For example, you take one value where sine is equal to a plus ib. Another one you take complex conjugate. Okay, that is b is equal to a minus ib. Okay, where ab are the real numbers I consider, I is the imaginary number is there. So here it includes all. Negative also is there, positive also is there, real is there, imaginary is there. Just what you will do here, make normalization with sine square, sine into sine star. It means a plus ib into a minus ib. If you multiply that, you will get the a square plus b square minus 2ab. All you will simplify yourself from the fundamental 8th class what we studied, where there is a value you will get a square plus I square into b square. Okay, then you will take the I square is equal to minus 1, so that it will remains only a square and b square. That will be, I will send a PDF how it is simplified. Okay, so that is not necessary to solve here. The fundamental is that if you take a plus ib and a minus ib, if you multiply, what is the a plus ib, what is a minus ib? This is also sine, this is also sine, this is the complex conjugate, this is the complex number. So add it, product it. Okay, sine to sine square, then you will get the real number only. So that real number you give another notation, say n square. That n square is equal to positive or finite value. Then if you know the positive and finite value of the particular position, then you can determine its probability where it is. So in this way you can make it normalization. Okay, second we will discuss very important bit. Definitely he may ask in the coming examination alternative semester, he asked that question. What is that? Schrodinger wave equation. Schrodinger wave equation. What is the Schrodinger wave equation? Already you know the wave function. What is the wave function, sir? What is the wave function? Wave function, you know, according to the last definition, this is the particle, this is the body, this is the, I will take particle some more big. Okay, it is visible. So now are you able to see this? This is the particle. So are you able to see this? Okay, see, you don't know exact position of this body, this particle, this electron, this material, okay, but we know the minimum, okay, where it is probability of finding the particle is there, okay. Now it is going to denote, or the particle make up a periodic variation. So periodic variation, this is called wave function. Or you take your birthday, for example, every April 1 you are having the birthday. So periodic variation, periodic means fixed, okay. In that particular point you are doing some function, that function you will call the your birthday function, like that only you are taking it. So that wave function, or to solve the fundamental mechanical equation of this wave, we have another one solution. That solution we call as a Schrodinger solution. He obtained, he gave you one solution. That solution is called as a Schrodinger wave equation solution, or Schrodinger time dependent and time independent solution. Okay, so why Schrodinger means Schrodinger only explained this one, okay, with the help of that wave. So, or it is obtained by solving the fundamental quantum equation, that is called as a Schrodinger wave equation. That's it. There are two types of Schrodinger wave equation. One is time, another one is a time independent. Time dependent and time independent. In the definition, in the heading only, it contains the meaning of that. Okay, one by one, see here. So we will give already one equation according to the Schrodinger. That equation I will go through here. Please go through the screen. See, in the screen it is not given the Schrodinger wave equation in the notes. So not necessary according to exam point of view. Only you are having how you obtain the Schrodinger time independent equation. That is important for the exam point of view. But we will know that what fundamental idea about the Schrodinger means is a solution. It is an equation to solve the wave, mechanical wave or the quantum wave. That's only okay. Now, sir, you use the time dependent, time independent words, sir. So one equation it takes care only time. One equation it takes both position as well as the time. So these are the two different cases are there. For your exam point of view, for your syllabus point of view, only independent, time independent wave, one dimensional. That too one dimensional. What is one dimensional? The particle is moving only x axis or the y axis or the z axis in this model. So here, okay. I am not considering in the three-dimensional axis, three-dimensional space. Okay, only one dimensional I am moving. So what the particle is having the velocity, what the particle is having amplitude, what the particle is having the frequency, what the particle having its wavelength. That with the respect of that, we will derive an equation. That equation gives you time independent equation. We will see that. That is the for the 10 marks derivation. Okay, we'll see one by one. Okay, now. He's not mentioned here in the notes, but I will tell you what is the time independent or the time dependent. This time dependent equation is minus h square divided by 8 pi square m square d square p divided by dx plus v into sine. So these are the notations are involved, complex notations are there. So it is difficulty to you to remember, but the complex notations are very easy. What you know the fundamental. H is the Planck's constant is there. 8 is the constant. Pi is also constant. M is the what is the mass I am taking in the bottle. That electron mass of electron is there. D square by P dx means what is that? P is the momentum. That you take the derivatives of that. It means variation. Derivatives means you is going to change it. Capital V I am taking the potential difference or applying the energy to push up or to pull it. So that is the potential difference. X means along with the x direction. This is there equal to minus I h divided by 2 pi d psi by dt. Here you see that x value is also there, t value also there. It means it is dependent. Time is there, dependent. It cares on both position x as well as time t. Okay, but this is not in your syllabus. So syllabus is that this coming equation, second equation. What is that? Time. What is that equation? Dou square sine by dou t square plus 8 pi square m by h square under into e minus v into sine is equal to 0. This we have to we need to obtain. This we need to derive. This we need to express ourselves how it is getting here. That we'll discuss. But equation is that here in this equation. See once again I will read. Dou square sine by dou x is there. It means position is there, plus 8 pi m by h is there. There is no t into e minus v is there. There is no t into sine is there equal to 0. It means it takes care about only the x. X means position, time is not there. Therefore, oftenly or it is oftenly referred as a time independent Schrodinger equation. That's it. Okay. Now we'll start the equation. These are the fundamental idea. You no need to write in the exam. These are these concepts. Okay. Now we'll start the derivation. So we'll come back again. ಇಂಕ್ ಇಂಕ್ ಬರ್ತಾ ಇಲ್ಲ ಅನಿಲ್ ಇಲ್ಲಿ ಇಲ್ಲ ಬರ್ಲತ್ತಿಲ್ಲ ಒಟ್ಟು ವೈಟೇ ಬರ್ಲತ್ತಿಲ್ಲ ಯಾಕೋ ಹಾ ಇದು ರೆಡ್ ತಗೊಂಡಿದ್ದೆ ಮತ್ತೆ ಹಾ ಪೆನ್ ಮಾಡೀನಿ ಪೆನ್ ಮಾಡಿ ಪೆನ್ ಹೊಂಟದ ಅದರ ಕಲರ್ ರೆಡ್ ತಗೊಂಡ್ರು ಹಾ ಹಾ ಬರ್ಲಂಟ ಈಗ ಹಾ ಕಲರ್ ಬೋಲ್ ಹೊಂಟಂತೆ ಪೆನ್ ಬರ್ಲ ಪೆನ್ ಹೊಂಟದ ಕಲರ್ ಇಂಕ್ ಇಂಕ್ ಬೀಳಲ್ ಹೊಂಟದ ಕಲರ್ ಪೆನ್ ಬರ್ಲದ ಪೆನ್ ತಗೊಂಡಿನಿ ಇಂಕ್ ಇಂಕ್ ಬರ್ಬೇಕಲ್ಲ ಪೈಲೆ ಬರ್ದ್ರ ಬರ್ಲ ಅಶೋಕ್ ತೋರಿಸಿದ ಅವನ್ ತೋರ್ಸಿನಿ ಹೆಂಗ ಹೌದು ಹ್ಮ್ Okay, I'm not getting the pen with substance same opposite background of the ink. So I will try to show by the cursor. Please look at the cursor here. So I am taking the one-dimensional wave function, okay, for the de Broglie's wave of the particle. So I use the word de Broglie's wave of the particle. You know that for this pen, what is the de Broglie wavelength? The de Broglie that is lambda is always inversely proportional to its mass or velocity or momentum. That is lambda is equal to h by p, that is there. So with the help of that, so you write the fundamental equation of the sine. Okay, that is, what is the fundamental equation of the sine? Sine equal to a into exponential of I into kx minus omega t. That we know the fundamental equations. Okay, where a is you take as a constant. Okay, e is the exponential value, I is the imaginary, k is a propagation constant, x is the position in which it is propagating, and t is the time, and omega is the angular frequency. So what angle it is going to change. So these are the values are there. If you bifurcate it, the same wave function, how we will bifurcate, sir? So a into e exponential power is there, no? Kx minus I omega t is there, no? You bifurcate, open the bracket, then a e I kx one side, a e to the power of a into omega t one side. One is minus, another is plus. So these two parts are there. Here, the points you are going to observe here, one is ikx, another is I omega t. One is x value, position, another one is the time is there. So both it is included. But our equation, it is independent. It means you need to delete, you need to remove the time. Then only it will come as a time independent only. So one by one step will follow it, how it is going to remove it, how it is going to obtain the required equation for that. So this called equation 1. Okay, where AEIKX represents the time independent only, that part of the wave function, and E is represented by sin is equal to I into A into EIKX. That only I am taking part, because as per our heading, only time independent part I took. This we call as equation number 1. Okay, next. Okay, go through the screen also. Oh my god, that equation number 1. Now you differentiate that equation number 1 with respect to x twice. What we'll get here, differentiating for that means, so sin is equal to a into e exponential power of ikx is there. So ik is here, propagation constant is there. Okay, so dou sin by dou x is equal to a, you take out can outside, then e to the power of exponential kx is there, I into k, it will come side, then remains what, same is the exponential values only. So differentiation equation. Therefore, you differentiate once again for that same. Okay, what you do, what the values of differentiation once, no, you differentiate again. You differentiate again for that. Then dou square sin by dou x square is equal to again constant you take. So another ik value will come same, 1a ik into e to the power of ik x. It will be. So again, I is the I square, kk is the k square, same a into e to the exponential power of ikx is there. Call this equation number 2. Okay, when you compare the equation 1 and equation 2, you will get the dou square sin by dou x square equal to, what is the value, 4 pi square minus lambda square into sin. You will get here. Okay, by comparing this equation, where minus I wrote here. What is the minus value, sir? Because I square imaginary number, it will be minus 1 only. So therefore minus 1. So how we will get the 2 pi by L is, sorry, 4 pi square by lambda, sir? Because the k value, the propagation constant fundamental value is what? So you know that angular frequency omega is equal to 2 pi of lambda is there. If you write the k value means 2 pi by lambda, 2 pi by lambda is there. Okay, so that 2 pi by lambda is equal to k. I want to write here k square. Therefore, 2 pi by lambda will becomes k square will become 2 square is 4 pi into pi square divided by lambda square. Therefore, I wrote here pi lambda, sorry, 4 pi square lambda square into sin. So this is the another equation we got from the fundamental solution. So this equation number 3. But according to de Broglie hypothesis, what we know, the fundamental lambda is equal to h into h by mu is there. Okay, so 1 by lambda can be written as 1 by lambda reverse means mv square by h is there. Mv means nothing but again momentum only. Mv means again momentum. M square v square is what? Momentum is only. Or 1 by lambda is equal to mv by h square. Mv by h is there, no? Square both side. What will get? 1 by lambda square m square v square by h square. M square v square nothing but how you will write? Is a momentum only. Is a p. Or we can write this as in the fashion of kinetic energy. What is that? Of if you take that 2m outside, so what will get here? 2m outside 1 by 2 into mv square divided by h square. 1 by 2 mv square, what is that? This is the energy, kinetic energy. Kinetic energy is going to denote by E. So please come to here. Okay, E. Okay. So E is equal to half mu square is equal to capital E minus V. Capital E is what? Kinetic energy or total energy for pulling, pushing, or changing its position for the particle in the bottle. So that is there. V is means total potential energy for that. So if you change, you draw the kinetic energy, then total amount of potential energy in the total amount of potential energy means the remaining value is kinetic energy only. Therefore, total initial minus final minus initial value, always you change of value, nothing but capital E is the kinetic energy minus potential difference capital B. Therefore, of is mv square or kinetic energy is equal to E minus of V. So that only in the simplified form only I wrote here directly. You cannot understand. This is the fact. Okay. So therefore, he wrote that is E minus V, nothing but is the kinetic energy. Wherever of mv square is there, directly I substitute the E minus V. So therefore, 2m into instead of half mv square E minus m. So 1 by lambda is equal to lambda square is equal to 2m into E minus V divided by h square. This we call as equation number. What is that? 4. Okay. Now from equation 3 and 4. Okay. 3 and 4. 3 is what? Dou square sin by dou square is equal to this value is there. And 4 is what? 1 by lambda square is equal to this value is there. So compare both. Once again you write dou square by sin by dou square is equal to whatever value of sin is there, no? Whatever value, sorry, sin, no? Whatever value 1 by lambda square, no? Substitute here. Here lambda square value is what? 2m E minus V. That same I substituted here. 4 pi square as it is 2m E minus V divided by h square into sin. So this, okay, come back. So this, okay, you take the one side only, you make a differential equation for that. So remains left hand side dou square sin by dou x square. So take this here, plus it will become 4 pi square and all these things into sin is equal to 0. Check this value now. What is the value? Dou square sin by dou x square position only, plus 8 pi square m E minus V by h square into sin. There is no time. Okay, it means it is the time independent equation. This equation often called as a time Schrodinger time independent equation for this particle what I put here. Okay, this. For example, it is a free. Free means a free particle. There is no binding at all. Okay, if you open the potential difference or no binding is there, no total energy is settled for that. Okay, in that time V will become 0. V will become constant. Or instead of that, for example, you take one ball, you give the force to that from the ball will come back only, but it will not change its potential difference. That's why it will treat as a constant. That constant here in the mathematical phenomena always treat as a 0. There is no change, only constant means we will treat as a 0. In the physical phenomena, wall is not moving, force is moving towards the wall, but wall is not changing. So energy is applying, there is no effect. Therefore, it will become constant. That is treating as a 0. Therefore, for the free particle, V substitute as a 0. When V is substituting 0, you will get g square by dou x square plus 8 pi square m E square. E minus V nothing but E only remains. This value is called as this is the time independent equation for free particle. That is the general particle. This is the free particle. You may write, go through the equation for that. Okay. Next heading we will discuss about the eigenvalues and eigen functions. Okay. I will discuss in the next class for that.